doing?
Good.
Good. All right, let's get started on this thing. This is 8th period. It's the 4th of February, 2019. Continuing on our exploration of right triangles, we are going to be learning some trigonometry. Trigonometry is just a fancy way of saying triangle measure. Trigon meaning three-sided things, triangles, and metry meaning measure. So literally triangle measure. All right. In order to handle trigonometry, we need to write things called a trigonometric ratio. All right, that's how you spell it. And you say it trigonometric. Perfect. What? Trigonometric. You try it.
Trigonometric.
Beautiful.
Trigonometric.
Yes, trigonometric. Blah. All right, so we are going to write trigonometric ratios. Fractions of triangle measures. That's it. That's all we're doing, okay? Angle-angle similarity allows us to say that these ratios, these fractions, are always going to be equal as long as one of those little tiny acute angles are equal. Okay, so we can have 400 triangles, but if they're all with one of the little angle measures at 10 degrees, then all of the trigonometric ratios for all these 100 different sized triangles, they're all going to be the same. Which is super, super useful because it allows us to calculate a bunch of really cool things, okay? But before we get into calculating and figure things out, I need to show you a brand new symbol in our language of written math. It's this symbol. It looks like a circle, looks like an O, that we put a belt on, but we didn't pull the belt tight to give this thing a tiny little waist, okay? We didn't turn it into an 8. It's still a 0. It just has a belt, okay? This symbol is called theta. It's a Greek letter. It's the letter they use when they want to make the TH sounds. Theta, okay? This symbol will be our go-to of, I don't know the angle measure, okay? Instead of the x, we're going to use theta. Okay? That way I can use x for side length and this for angle measure. No big deal. Yes? Yeah? All right. Let's talk trigonometric ratios. The first ratio that we have is called the sine, spelled S-I-N-E, sine. But when we write it in math equations, it is written S-I-N. Please don't say sin. This is not the sin of A. A is not a bad person, and neither are we. So we are not going to say the sin of. We are going to say the sine of. Okay? The next one seems like it's sine's cousin because it's written C-O-S, but please don't say this is the cos of A because this thing and A are not related. They are not cousins. This is the cosine. So you're going to say sine and cosine. 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 The last one is written this way. It looks like you're writing it as tan, but I'm sorry, the tangent does not go to the beach and get some rays. Please don't say tan. I'm very bad about saying tan. Please stop me, yell at me if I say the tan of A. It's not tan of A. It's tangent of A, okay? He's not going on spring break, okay? No tans for this one. All right. Let's write the ratios. The first one, the sine of any angle, which we're representing with theta, is always going to be equal to the ratio, the fraction, of the sides opposite the angle and the hypotenuse of the right triangle. Let's practice identifying opposite and hypotenuse. In our right triangle, here's our right angle, which makes which side the hypotenuse? The one across from it. This side is the hypotenuse. Always the hypotenuse. Now, depending on which angle you're looking from, opposite and adjacent change. Okay? So let's practice looking at this from A's perspective. The sine of A. Here is angle A. I'm going to take a pencil and I'm going to point at angle A. There's angle A. Now if I look at that pencil like it's pointing at A, which side is it also pointing at? Side A. That is the side opposite that angle. Okay, I'm going to color this one in pink. Now I told you that the opposite side could change, but the hypotenuse never ever will. So what is the hypotenuse of this triangle?
C.
Good. All right, let's do this again for sine, but this time we're going to do it from angle B's perspective. Here's angle B. What side is opposite angle B?
C. B.
Side B. Very good. And I'm going to color it a different color so that you can see it. The sine is always opposite over hypotenuse. What's the hypotenuse of this triangle? C. All right. Feels okay? Yes? Not yet? Okay. Ask me a question. If there's no questions, do me a favor and flip to the back, and we're going to look at the example on the bottom. Number 1, we want the sine of J. The sine of any angle is the opposite over the hypotenuse. I'm abbreviating, OPP for opposite. Yeah, you know me. And HYP. Yes, spoilers. All right, here's angle J right here. What side is opposite angle J? What's the measure of the side opposite angle J?
L.
12. It's the measure of the side. What's the hypotenuse of this right triangle? Very good. Reduce this fraction and then give it to me as some sort of decimal. To 2 decimal places, please. Use your calculators. Reduce the fraction. Give it to me in decimal form with 2 decimal places, please. 0.60. And then the reduced fraction? 3 over 5? Okay. Easy enough? I'll let you do the second part of number 1 on your own a little bit later. Come back to the front page. Now that we've figured out sine, let's go ahead and do cosine. The cosine is always given by the fraction of the side adjacent to the angle divided by the hypotenuse of the right triangle. Let's practice. Looking at angle A. What side is adjacent to angle A?
A.
Adjacent means next to. So if I were looking at this angle, right here, I've already decided that this is opposite it. This is hypotenuse, which means this one has to be adjacent. Hypotenuse we discovered in the previous one. Now looking at this from angle B's perspective. There's angle B. This is adjacent over hypotenuse. Which side is adjacent to angle B?
C.
C is the hypotenuse. So which side is adjacent? A. Very good. Easy enough? Do you feel that you could do those other two examples on your own now that you saw how to do the sine one? If I flip back to the front page, let's do this one. Ready? All right, so the cosine of any angle is adjacent over hypotenuse. What side is adjacent to angle J?
A.
That's an angle. What was the number?
32.
32 is correct. And the hypotenuse of this triangle?
40.
Reduce that fraction and then give it to me as a decimal. Okay. I'll let you guys finish that on your own because you guys seem really good at doing that. 0.8, he says? Okay. Come back to the front page. We have one left. The last one, tangents. The tangent of any angle, which we'll call theta, is given by the fraction between the side opposite the angle and the side adjacent to the angle. Looking at angle A, which side is opposite angle A?
B.
That's the hypotenuse. Try again.
B.
Opposite.
A.
A. What side is adjacent to angle A?
C.
D.
That's the hypotenuse. Try again. Yes. You're not, this is really tricky to see them. It's okay. Let's look at it from angle B's side. All right, ready to try again? Ready to try again? From angle B's perspective, there's angle B. We want the side opposite angle B. Yes. And we want the side adjacent. That's the hypotenuse. Yes. You're not wrong that C is next to angle B, Ethan. You're not wrong that C is next to angle B. But C is already called the hypotenuse, so it can't be anything else. Okay? All right. Flip the page. Here at the top, we're going to look at number 3. We're going to do number 3 together. The tangent of any angle is given by the opposite over the adjacent. What side is opposite angle J? It's a 6, but 36, yes. You were looking at this one, right? Yes. No, you're right. It's a 6 though. Which side is adjacent to angle J? 12 what? Yes, 12 square root of 3. You'll want to reduce that. I don't think the calculator can reduce this for you. You may have to do it by hand. And then get me a decimal number, rounded to 2 decimal places. And if you stick this in the calculator, it can give you a decimal. No problem. Okay? I'll let you guys finish that. Not too terrible, right? Now, the trick behind all of this is to get this stuff memorized so that way everything becomes faster. So what we're going to want to do is we're going to want to memorize those highlighted boxes. And for that, I have a little sentence for you. Do you remember in Algebra 1 when we were trying to get you to get the order of operations memorized? What was the little sentence we asked you to memorize? Yeah, with PEMDAS, but what was the little sentence that came with that? Do you remember? Please excuse my dear Aunt Sally. That's the one I learned like 20-something years ago. So it's really old, that particular phrase, but it still works. Here's ours. This word, SOHCAHTOA. Yeah, it sounds like suckato. But if you were to write out that word suckato, it wouldn't look like SOHCAHTOA, and this has all of the information you need with all of those fractions. Okay? So I'm going to rewrite it down here, and as I'm rewriting, I would love for you to watch, because each letter I write is going to be a different word of this sentence I have for you, that when I heard it in high school as your age, like 20-something years ago, I went, what? Teacher said, oh my God, what? And I freaked out. And I'm pretty sure you guys are going to freak out too. So, ready? Okay, take a look. Some old hippie caught another hippie tripping on acid. Some old hippie caught another hippie tripping on acid. But those letters all stand for sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. All right?
Some old hippie caught a hippie.
Another hippie, yeah.
Some old hippie caught another hippie tripping.
Yep. So if you just write the letters of that phrase, and I recommend that you write it like this, because this shows you the fraction. Whereas this doesn't, this shows you what the fraction looks like. So write, some old hippie caught another hippie tripping on acid, and you'll see which side goes to which trig ratio.
Oh, so opposite, hypotenuse, adjacent, hypotenuse.
Do me a favor. Using some old hippie caught another hippie tripping on acid, relate those letters right here to sine, cosine, tangent, opposite, hypotenuse, and adjacent. Fill out these letters right here. Sine, opposite, hypotenuse, cosine, all of that stuff. Using your thought of some old hippie caught another hippie tripping on acid. Yeah. Yes.
You sign opposite the what?
Opposite, the H is hypotenuse.
Oh.
The H is always hypotenuse. The O's are always opposites. The adjacent, the A is always adjacent. C is sine, or S is sine, C is cosine, and T is tangent. Give me a thumbs up when you have this part filled out. I know you do. Thank you. I got my first thumbs up. Thank you. Second, third, fourth, fifth, sixth, seventh. Eighth, ninth, 10th. We're waiting for all filled out right here?
Oh, yeah.
Yes? All right. Last one. Diligently getting it down. You got it? Yes? Awesome. All right. We can use that to help us set up equations and solve. for missing side lengths. Think about this. Up until right now, if I gave you a triangle with an angle measure and I said, give me the side length, you would look at me and go, duh what? Don't know how to do that. Now, because it's a right triangle, we have the power to do that. Let's figure out how. Take a look at this triangle. What information do we know? I know one of the acute angles. I know the right angle. Because I know where the right angle is, I know where the hypotenuse is. Now, one of my sides has a variable. Yes? Is that side opposite or adjacent the angle I was given? Is this side opposite the angle or adjacent to the angle? It is opposite. So this is my hypotenuse. This is my opposite. And because I have opposite hypotenuse, I have the setup for sine. Here's my setup. The sine of any angle equals opposite over hypotenuse. Here's the measure of my angle. Here is the side opposite. And here is the hypotenuse of my triangle. Did you see how we set up that equation? Let's see. All right. What's happening here between the x and the 12? That's my phone. Sorry, it's mine. What's happening between the x and the 12 right now? Yeah, it's dividing. How do you undo division? It is a fraction. We're trying to get rid of the division of the fraction. Okay, I heard turn it into a decimal. That just changes the way it looks. It's still technically a fraction. I want to get rid of the fraction altogether where all I have is no more division. How do I undo division? Multiply. So I'm going to multiply both sides by 12. That gets rid of this. So here, no more divided by 12. And here I have 12 times the sine of 21. And it looks like from this step, they changed the sine of 21 into 0.3584. So let's go figure out how they did that. Calculator time. Calculators are wonderful because when my dad took this class, when he was in high school, like 40-something years ago, look, my dad is really old, okay? It was a long time ago. No, it was longer ago than that. Oh my goodness. Wait, let me think. When was my dad in high school? My dad was in high school in the 1950s. Oh, my dad is old. They didn't have calculators like this. They didn't even have like the regular 4-function calculators. No, they had to do all this stuff in their brains. But these numbers are so hard and so weird to do in your brain. They literally had a book of the trig functions that basically said the sine of 21 is 0.3584. The sine of 22 is, and then it would be a different number. Like, it was a book like that, and he had to go look it up. We don't have to do that. We have a calculator. Let me show you how to look it up in our calculator because it is so much faster. Turn on your calculators. Get to the home screen. Create a new document. Don't save what's there.
So you want us to erase what the last
You can
two-
erase it. Yep. Now, you need to look right up here at the life bar of your calculator, the battery power. Does it say DEG? Oh, good. If it doesn't say DEG, we need to fix it. Let me show you where to go to fix it, and I'll explain what this DEG means. Go back to the home and go to settings. Under settings, you want to be in document settings. Now in document settings, you're going to see an option for the angle. And if I were to select this, I would see my different options: radians, degrees, and gradients. All these are just different ways to measure the angles. We're used to degrees, the stuff that our protractor uses. Each of these are a degree. A radian does the same function, just the size of the tick marks are different. That's all. Okay? It's like the difference between feet and inches. Okay? And we can convert between one and the other. I'll show you that later. But for now, we are going to live in degrees. Okay? So once you've made sure that you're in degree mode, changed it if it's not. All right, we're going to come in here and add a calculator page. So add a calculator page to your document now, please. And your calculator should look something like this. We need to create the trig functions. Find the trig button down here by the number 7. Press the trig button now. When you press the trig button, you should see a pop-up menu. Look, our trig functions, sine, cosine, tangent, and beneath them, their evil twin with the black hat and the curly mustache, sine inverse, cosine inverse, tangent inverse. These inverses undo the trig ratio right above it. We'll play with that likely tomorrow. These other ones you'll see in Algebra 2 maybe, pre-calc, calculus. You don't have to worry about them right now, but you know where they are when you get there, okay? Let's play with the ones that we're working with right now. Pick your favorite sine, cosine, or tangent, not the evil twin inverses, okay? Sine, cosine, or tangent, doesn't matter, just pick one. And then type any old number that you want in there. It doesn't matter what the number is. I like keeping it like an acute angle, so somewhere between 0 and 90. Hit enter, and it spits out a number. You basically did the thing that my dad was having to do, looking it up in books with like really tiny font. I went to see him for Christmas. I tried so hard to grab that book so I can bring it and show it to you, and he refused to let me have it. He doesn't use it. He uses a calculator like this now when he wants to find sines and cosines and things. Look, he still does. He's a nerd, okay? But he wouldn't let me have the book to show you. So mad. Dad, if you're watching this video, please let me have the book for Christmas. My birthday's coming up. Hashtag gifts. Okay. Let's go back to what we were doing. All right. We're trying to find how they got, oh, we know how they got this number now, yes? So then let's figure out how they got this number. Type in 12 times the sine of 21. Literally type 12. Then bring up your trig menu. Select the appropriate trig ratio, the trig function. Type in the angle measure. Hit enter. You're done. Like that's it. Really easy, right? All right, let's do the next one. All right, what information have we been given about this triangle? I have an angle. I know where the right angle is, which means I know there's the hypotenuse. The other side leg that I've been given, opposite or adjacent to the angle that I was given? She's saying adjacent. Do you see it next to it? This side is next to the angle we've been given. It's the adjacent. So I have hypotenuse and I have adjacent. Which of my 3 trig functions uses adjacent and hypotenuse? The cosine. Very good. So we're going to set up our equation as the cosine of the angle measure equals the adjacent over the hypotenuse. Now we want to solve for x. What's happening between the 20 and the x right now? Dividing. The 20 is being divided by the x. I have to get rid of that division before I can do anything else. Multiply. What do I multiply by? What is being divided? What are you dividing by? You're dividing by x, so I should multiply by x. So whatever we're trying to get rid of is what you do the inverse. Okay, this looks weird, yes? But this is how it's written. This means x times the cosine of 42. I've written the multiplication symbol in there for you. As we move forward, I'm gonna start taking that multiplication away. You have to remember, it's there even though I don't see it. I want x by itself. Is it by itself? No, it's being multiplied by the cosine of 42. Please say cosine, not cos. Cosine. Cosine. Okay. Okay, don't get mad at me. How do I undo multiply by cosine? Divide by cosine of 42. We have to divide by all of it. That gets rid of this. And so my answer, x, is whatever number I get when I take 20 and I divide it by the cosine of 42. Go to your calculator, gentlemen. Gentlemen. Go to your calculator. And we are literally going to type this. So I want it to look like a fraction. So control divide gives me the little fraction setup. 20 in the top, cosine 42 in the bottom.
What do you press for that?
For the little fraction thing,
For the cosine?
hit the trig button next to the number 7.
Okay.
And then enter. And what number did we get? 26 point, round it to the nearest hundredth?
27.
91?
Oh, yeah.
Okay. Let's set up the last one. We've been given one of the acute angles in a right triangle. Here's the right angle, which means there's the hypotenuse. What is the measure of the side opposite the angle we've been given? X. Very good. It's our unknown. What is the measure of the side adjacent to the angle we've been given? 8. I have no information about the hypotenuse at this time. So as I'm looking at my trig ratios, I want to figure out which is the only one that doesn't need hypotenuse. Which stands for? Very good. So let's set up our equation. The tangent of the angle is equal to the measure of the side opposite it divided by the side adjacent to it. What's happening between x and 8? What's happening between x and 8? Dividing. How do you undo division? Beautiful, by multiplication, and as you said, we're going to multiply by 8. It gets written 8 tangent 63, but that really means 8 times the tangent of 63. And so go to your calculator and literally type 8 tangent 63. $15.70. Okay. That's it. That's all there is to this. Thank you. Bye. Bye, Dad. Don't forget to give me that book for my birthday. It's coming up. Just saying.